Hello everyone, this is the first lesson recording for IM1, March 5th, 2021. We started off by doing the quiz number 3, so if you missed it for whatever the reason, please contact me as soon as possible to arrange a time to make this up. The retake opportunity for the quiz that you just took is going to be available if you scored 80% or lower. Study hall is required if you scored 60% or lower, and that's going to be on Monday. That's coming Monday at 10:10 a.m. in my study hall, and then the actual retake will be happening on Tuesday at 10:10. What are we doing today? We are going to be looking at tennis balls. So game, set, flat, and it is called balls and balls and more balls. And we are going to be looking at Desmos card number 1 to 5, where we'll be dealing with exponential decay. So please pause the video and get that started. Here we go. This is the first card. You own a tennis ball manufacturing company. This is one of your good tennis balls. An angry employee just added a bunch of bad tennis balls to a shipment. Your job is to figure out which tennis balls are bad. What do you think makes a tennis ball bad? Looking at this tennis ball, what are some qualities you might be looking for when you are determining if the ball is good or bad? Probably the most specific thing would be how well they bounce, because nobody wants a tennis ball that is too flat or too bouncy, because then it's not really predictable. Card number 2. Can you tell the difference between a good tennis ball and bad tennis ball? Let's get your guesses first. Okay, so looking at this, if you had this tennis ball, would you like this tennis ball if it just dropped from this height and it bounces and then not very much and then stops? This will be kind of hard to play tennis ball with. So my thought is that it will be bad. It just does not bounce enough. What about this? Okay, it bounces pretty well. Okay, so I would say it is pretty good. It bounces, the first bounce is maybe about halfway up, so maybe that's pretty good. And 4, 5, 6. It takes 6 bounces until it becomes more like stationary. It doesn't bounce anymore. So I'm going to say it's good. What about this one? 1, 2, 3, 4. 1, 2, 3, 4. Okay, so it bounces pretty well first time, and second time and third. Okay, so I'm going to say this is pretty good. And it bounces for at least 4 times before it becomes stationary or becomes flat on the ground. Alright, can you tell the difference between good tennis ball and the bad tennis ball? Let's get your guesses first. Do you think this ball is good or bad? 1, 2, 3, 4, 5, 6. I would say this bounces a lot more. I'm going to say it's good. And that's my thinking. Let's get back to our slides. Game, set, flat. Let's have math help us. Okay, instead of just subjectively just guessing, oh, that kind of looks good, that doesn't. That's very subjective. There's no way of saying this one is good, this one is no good. Okay, so we want to have more of a definite standard than say, oh, that kind of looks good or that kind of does not look good. So use the corner plane. What we're going to do is we are going to be putting the bounce. So if this is where the first point is where you are dropping the tennis ball, and then the second point, this green, is where after the first bounce, how tall, how high the ball will bounce. Say if this is up here, that means the ball bounces went down and then went up all the way, then went up, then up all the way, and so on and so forth. Okay, so it's going to look like that. So that's measuring the height of the ball versus the bounce number. So at bounce one bounce, the first bounce, the highest height reached is over here. Second bounce, highest height is reached here. Okay, so what do you think for your ball? Where do you think it will go up to? So you're going to work on card number 6 and 7. So card number 6 says, it isn't easy to tell if a ball is good or bad just by looking at it. Let's learn some math that will help us know for sure. First, drag the bounce height to create any kind of tennis ball, then press bounce. Let's just press it as it is, and then we'll start adjusting it. Okay, so 2, 3, 4, 5, 6. Okay, so that's how it goes. That's the first bounce reached up here, and so on. So if I move this, I need to press reset. I can move this, and depending on that, that's going to be what your bounce will look like. So let's say I want the first bounce to be, let's do something crazy. First bounce not so high, but the second bounce is really high, and so on and so forth. Okay, and then this is what it's going to look like. So I know this is kind of crazy. I don't think you'll find any balls that do that, but that's how you're controlling the bounce. So what do you think your ball will bounce like? Okay, so I'm going to say, oh, maybe it's going to, maybe first bounce, it's going to reach that height, and the second height time it's going to reach this high, and this high, and this high, and so on. Okay, so maybe it's going to bounce like this. 4, 5, 6. Okay, so this is how you're controlling the bounce, or what the graphing really represents. Card number 7. Now drag the bounce height to create the tennis ball that you know is bad tennis ball. Okay, so if it was bad, that means it's really not bouncing very much. So I'm going to say, okay, maybe the first bounce, it only goes up here, and then the second bounce, it really just doesn't take very long before it stops bouncing. Okay, so by third, by fourth, it really does not bounce at all. And I would say it bounces for about 2-3 times, and then it is just on the ground. And the first bounce, it really does not bounce very high at all. That's why I think this is going to be bad. Alright, that tennis ball is bad, just like we asked you to make it. Here's why. The first bounce rebounds 27%. So this, from this point to 1.08, 4 foot to 1.08, that's 27%. Remember how we worked with percentage last lesson? So that would be the current divided by previous. 1.08 divided by 4 is actually 27. Okay, that isn't bouncy enough. The International Tennis Federation has ruled that tennis ball can't rebound more than 58% or less than 53% of the way to its drop height. That means we need the bounce height to be between 53 to 58% of the previous height. Now let's make this tennis ball a good tennis ball. Adjust the bounce height, then select bounce and analyze to see if it's good or bad. Okay, so we want 53% of 4. So we're starting with 4, so we want 53% of 4. So that means we are going to be multiplying 0.53 to the times 4. Or if I'm just doing a rough, I know that this will be halfway, 50%. I want 57%, maybe about here. Or actually, I don't want too much. Okay, so then I want halfway of that. Maybe that's about here, but maybe a little bit more. Halfway of this, a little bit more. Halfway of that height, but then a little bit more, and then halfway of that height, and then a little bit more. Let's just check this out. Okay, so the first bounce is good, but the second bounce from here to there, it is bouncing 60%. 60% is too big. We want it to be less than 58. So I need to bring that down. So I am going to bring down the second bounce a little lower. Okay, and that means I'm going to have to bring down the other ball too. Okay, let's see if this works. Okay, so the first bounce is good, the second bounce is good, the third bounce is good, but the fourth bounce is 71%. Oh, that's way too much. Okay, so I need to bring the fourth bounce down. Okay, and you can see the numbers. 0.7. What's half of 0.7? That's 0.35. So maybe 0.39 would be good. 0.39. What is half of 0.39? That's approximately 0.2, but I want a little bit more than that. So maybe 0.2. Okay? Alright, let's try this. Alright, so your fifth ball rebound is 51%. 51% is way too low. So I need to bring that higher. So okay, let's do 0.22. Let's see if it works. Okay, 4, 5, 6. Okay, so now this is a good tennis ball, and we'll tell you why. The first, every bounce is lower than every previous bounce, and you are respecting gravity, therefore gravity will respect you. Second, every bounce rebounds rate is between 53 and 58% of the previous bounce. Good tennis balls aren't too bouncy and they aren't too flat. Okay, now we're going to be looking at the model in card number 9 and 10 by trying to graph or draw a graph of the bounce. Okay, so go to card number 9. Alright, the select function that best models your tennis ball. This is what I had plotted to be a good bounce. And so every bounce is between 53 to 58% of the previous height. The first thing I need to do is decide, is this going to be a linear function, quadratic function, or exponential? Notice this shape here. Which shape is this one going to be? It is going to be exponential. Okay, so then it's going to pull up a bar that is I can adjust. I do know that it starts at this 4 right there. So I am going to move that dot to start over here, and then I can move the other dot to mimic an exponential point. Okay, so I can okay, that looks pretty close. Okay. Alright, I'm gonna go with that. Alright, so that seems to go through most of the point pretty accurately. Alright, so card number 10. So this is the equation of the line that I have just chosen. Okay, so the equation of the line, the Desmos has calculated for us. That is 3.87 times 0.57 to the power of x. In the context of tennis ball, what does 3.87 mean? Okay, so what does it mean? Remember, when you have exponential function, it is always in the form of y equals a times b to the power of x. And we have said that the a is the same as the initial value. And we said that b is the same as the multiplier. Okay, so that means that 3.87 represents the initial value, and then 0.57 is the multiplier, or in this case it's the 57%.